You hit record. So the first two sections of that article, a promise represents the eventual results of an asynchronous operation. So essentially, promises are another substitution for callbacks. We can use them pretty much in the same way. But if you look at the second section there, why use promises? So promises provide a simpler alternative for executing, composing, and managing asynchronous operations when compared to traditional callback-based approaches. So promises and callbacks, they kind of do the same thing. Promises are a simpler, more elegant way to do the same thing. So that's kind of the gist of why we're talking about this today. I think for homework, either tonight or tomorrow, so jQuery has promises built in as well. So we'll take a look at what jQuery promises can do for us. This stuff is really important when we get to databases starting Thursday. You can use callbacks with databases, and a lot of the times callbacks are fine. But if you start getting into some really dense pieces of code, or if you're trying to chain several different asynchronous operations together, then we want you guys to be aware of promises, because this may be a more elegant approach and way to structure your code. So let me paste the lesson README back into Slack in case you lost it there. So this is what we're going to be walking through. I'm going to be skipping around a little bit. This is a pretty dense lesson. I just want to hit some key points, and then we're going to code along and see an example of promises. It's one of those things, kind of like constructors this morning. I feel like it's easier just to kind of walk through it and do it than try to explain it. And so that's kind of the goal for this afternoon before lab time. So quick pop quiz as we get started. So taking a look at these two blocks of code, which do you think will finish first? As soon as my screenshot loads, there we go. So if you take a look at that first block, you have a console log of red and a console log of blue. So go ahead and type into Slack for the first block of code there, the two console logs, which do you think will fire first? Will we see a console log of red or a console log of blue? And if you want to try it out, you can just recreate that down in your DevTools. Yeah, absolutely. So this one's pretty straightforward. The red console log is going to fire before the blue. Now, what about that second block of code with the set timeout? Which one is going to fire with that block of code? Is the red going to fire first, or the blue is going to fire first? Yeah, so the blue is going to fire first. So why is the blue going to fire first in that second example? Yeah, the set timeout. So the set timeout takes a callback. And so when we have a callback with an asynchronous operation, even though that set timeout is set to 0, it's still going to be affected in the JavaScript stack, right? So it's going to affect the order of operations and how JavaScript approaches that code. And that's the gist of what promises, what callbacks, and as we see today, what promises are going to do for us. So to sum up, since JavaScript code is non-blocking, it means that each line of code begins to execute as soon as it possibly can, including before previous lines of code have finished executing. Now, isn't that really confusing? How could anyone write code when they can't be sure about the order in which their lines will run? That doesn't seem like a good approach. Well, most of the time, each line of code executes so quickly that you don't really notice. But when you want to do things that are slow, take a long time, that are very memory intensive, this asynchronous behavior becomes very important, and we need to leverage it with JavaScript. Now, here's a sample of a couple of instances where you may want to use callbacks and promises. And this is a little bit more robust than just like a click event on some sort of DOM element. But this stuff really comes into play, this non-blocking behavior in JavaScript. For example, if you're waiting on a DOM event driven by user interaction, so that's like kind of your low-level click events or hovers, waiting for a response to an HTTP request. So we've all been to websites nowadays. It's in fashion to log in using your Facebook, log in using your LinkedIn, right? So if I go to schmittiapp.com and I'm going to log in with my Facebook, I have to put in my credentials or click on the Facebook button. And then that app makes a request to the Facebook server, so the Facebook API, right? It validates, authenticates my credentials, and then sends that request back to the app so I can actually access it. So that's a pretty long round trip. It's a pretty long process. So it would make sense to make some sort of asynchronous code. So while it's making that Facebook request, usually you'll see maybe some sort of spinning, a spinning something in the DOM, or maybe it says like, requesting from Facebook, is this your profile or your avatar pic, something like that. Waiting for a database to retrieve or modify a piece of data. So depending on the size of our database, how dense it is, like that can take a while to grab some stuff from a database. Waiting for a timer to run out, waiting for the file system to read from or write to a file. Sometimes that can take a minute. And then hitting a third-party API for authentication. So I just mentioned that one, but let's say that you want to integrate, the Yahoo stock ticker in your app. That's going to be a request that you make to those Yahoo or Google Finance servers to get the most updated information. Or if you're trying to get the March Madness sports scores, right? That's a lot of requests and response delay time, perhaps. So why not just use callbacks for all of this stuff? Well, has anyone heard of the phrase callback hell before? Has anyone heard of that? Okay. Mike, I saw you raise your hand. So what is callback hell?
I don't know exactly how to describe it, but it seemed like it was basically you get in a series of like callbacks that call each other, and it just gets overly complicated.
Yeah, so if you have a lot of callbacks, if you have a lot of operations that are depending on previous operations and such, callback hell just refers to you have events nested within events nested within events. And the way that you write that code traditionally is with indentation, right? So callback hell refers to that really dense piece of code that looks kind of like a crazy triangle, and then it comes back in. So it's really hard to follow. I just pasted a URL into Slack called callbackhell.com. We won't take time to read it right now, but it has some really good suggestions at the bottom of the article on how to try to prevent callback hell. And one of the suggestions, obviously, is promises, which is one of the really great advantages to using them. So if you want to check that out, please do. I'm going to put in another piece of sample code just to demonstrate what callback hell may look like. So this line of code, we don't have to go through the whole thing. You can kind of read it on your own. But this is not an atypical use case when we're trying to do some database operations or trying to read a file. You may have something similar like this. So this piece of code needs to do 5 things. It needs to read in data from a particular file. It needs to parse that data as CSV content. It needs to use the content to make some sort of HTTP request externally. It needs to take the response from that request and store some data in a database. And then finally, send a response back to the user. So those are 5 asynchronous, pretty dense operations. And actually, this piece of code doesn't even look that crazy. I mean, it can get a little nuttier than that. This is more like callback purgatory. I don't know if I'd call this full-on callback hell, but this is an example of that nested structure. So not only is it hard to read, but you really get lost, trying to, if you want to maintain this code, because it's easy, you can't really keep up with it. So this is a big problem that promises will solve. So in addition to callback hell, there's a couple of other drawbacks to perhaps using callbacks. Callback hell is the first one. The second one is that when we're dealing with callbacks, generally speaking, each callback that we create, you have to write an error handler for each one. So each one requires an individual additional error handler. So that becomes really messy after a while. And Promises helps us alleviate writing individual error handlers for each callback. And then finally, in complex programs, it'll be hard to tell in what order callbacks fire. So that goes back to the indentation, to the readability of the code. It's really hard to figure out what order stuff is happening in. So there's a better way to accomplish all of this, and that's with promises, which is why we're going over them today. Any questions so far? And just to be clear, promises and callbacks, they essentially accomplish the same thing. They're both ways to write asynchronous JavaScript. And again, for like your basic event handlers, click events and stuff, most of the time a callback's going to be fine. But we want you to have exposure to promises because it's more elegant, particularly as we move into databases. And if you have several operations that need to fire, promises may make your life a little bit easier. So this isn't like the only option. It's just a more elegant option if the use case calls for it, which is why we're touching on it.
So the only time that we would want to use or need to use promises then is with the database stuff? You're saying?
No, I don't like that word only. I would suggest it's kind of a preference. If you're comfortable with callbacks, that's totally cool. But some of the use cases would be databases.
Is there a reason to not just always use promises all the time?
Sometimes I just like the brevity of callbacks. Like if I'm doing a click handler, I really don't, it's so ingrained at this point, I don't really need, because promises also have their own complexities, right? And it's the right tool for the job. Like I said, I think Christine for homework tonight is going to show you guys an example of using jQuery promises. So you can use promises with particular jQuery type of events, particularly if you're trying to hit an API, hit an API, like an external API. For example, if you want to have some sort of movie app where when I type in Matrix, I want to see all of the information for all of the Matrix movies, right? So I'm going to have to go out to Rotten Tomatoes or IMDb, grab all that information, and then render it onto a web page. So there's several steps involved in that, not to mention if my server is slow or the Rotten Tomatoes servers are slow, it's just going to, compound the lag and such. So jQuery has its own syntax for using callbacks. However, you can use promises for that as well. I would just say that promises, it's a more current way to write asynchronous code. And as we'll see this afternoon, when we look at an example, you may find it much more readable. If you have several different operations if you have like 5 operations that you need to chain together, I think you'll find that promises are a little bit more elegant. But if I'm just need one thing asynchronously done, I'm probably just going to use a callback just for simplicity's sake. But I'll leave that up to you. If you like promises, then you can crazy go nuts with them for sure. So why promises? We talked about this. Well, your article addressed this, but promises are an alternative way to directly using callbacks. They kind of accomplish the same thing. They just do it in a different way. Promises allow us to write asynchronous code that looks like synchronous code. So it looks much more structured. It's much more readable, easy to follow. Promises create the illusion of returning values or throwing errors from within our callbacks. So while promises do not replace callbacks, promises actually depend on callbacks. Don't get too caught up on that. But some of our promises will take callback functions. But they provide a layer of abstraction between you and callbacks, enabling you to prevent callback hell. Promises offer several advantages. They make asynchronicity explicit, just like callbacks. Unlike callbacks, they clarify the order of execution. So in one of the previous screenshots, that was one issue with callbacks. Sometimes you don't know exactly what order your code is going to fire. And so promises help alleviate that issue. They're easy to read the callbacks, and they can simplify error handling. So for example, we're going to code up an example here shortly, but if I have 5 callbacks that I need to put into some sort of operation, again, I would need to create some sort of error handler for each of those 5 callbacks. Well, promises gives us a way to create kind of a safety net at the bottom. So if I have any errors that happen within the chain, just let me handle that at the end of the chain after everything else fires or fails. And so we'll see how that simplifies our code as well. There's a lot of images and charts on the anatomy of a promise. This is kind of a really basic one. It hits the main components of a promise. The other reason that we're covering promises after today's coverage is that a promise is a type of constructor function. So we're going to be using that new keyword to create new promises going forward, which is pretty cool. And as soon as my screenshot loads, there we go. So you'll see a lot of these images out on the interwebs, but this is just a really simple one. Bear with me. Let me try to copy that again. Okay, I'm just going to share my screen for a minute. My imager is a little slow right now. So yeah, I'll just point your attention to this anatomy of a promise diagram in the README. So the role of a promise, so this big blue box, you could consider that a constructor function for a capital P promise. So we would do new promise and then pass in some information to it. And that's what we're going to do here shortly. But generally speaking, a promise is either in 3 states. It's either resolved, which means it successfully finished what you told it to do, or it's rejected, meaning something failed, something didn't work properly. Maybe you try to send a promise that will grab some information from Rotten Tomatoes, and maybe Rotten Tomatoes, maybe their servers are down, or maybe you misspelled the word matrix, and so Rotten Tomatoes doesn't know what to do with the query that you passed into it, right? So that promise was rejected. It wasn't completed. And then the final state that a promise is in, and I think this was from your article, it's in a pending state. So pending just means that it's still in process. So it's not rejected. It hasn't been fulfilled. It's still, like making that request to Rotten Tomatoes, for example. So those are the 3 states that a promise is in. Pending, rejected, or resolved is the technical term for that. And let's take a look at how to use a promise. I'll just scroll down a little bit more, and then we're going to walk through an example we can code along together. So using a promise, some of this is a little wonky, so just bear with me. A promise takes an anonymous function with 2 parameters that resolve and reject handlers. The promise resolves when resolve is called and rejected when reject is called. There's also promise.then and promise.catch. So these are 2 methods that the promise constructor function gives us that allows us to chain different behaviors and asynchronous operations together. Then the .catch generally will be that's their safety net, or that's kind of the last thing that we would chain on. .catch is generally the error handler, or if something's rejected, let me do this in the .catch method. So let me console log it. Maybe I need to put something to the server logs. Maybe I need to refresh a page because the form didn't go through properly. And all those types of rejection states would be handled in the .catch method. In this screenshot here, or this line of code, let me see if I can screenshot it one more time. I'll see if that loads up. Oh yeah, now it's working. So in broad strokes, this is how a promise would be kind of chained together and coded. So we would create a new promise using new promise constructor, and maybe we assign that to a variable called SomePromise. I didn't put that code in here, but for assumption's sake, we'll say that SomePromise is a promise object. And let's say that after that promise is fulfilled, then I want something else to happen. So for example, maybe that promise was the call to the Rotten Tomatoes database. And if that promise is fulfilled, then I want to take that data for the matrix and create a new DOM object and have it append to my page with the poster, the year of release, the actors, the actresses, the reviews, things like that. So once I get that data, once it's returned, then do something else. However, if something fails along the way, maybe I'm going to create a .catch method. And so this catch method would catch the rejection value or the rejection callback, whatever I want to happen in case the thing, this entire series of operations blows up on me, I want to put some code in my catch method. But generally, this is how it would be chained together. So you can do .then, you can do multiple .thens just to chain the order of operations. It's very readable. The indentation is much simpler. And you can also follow this promises syntax much more clearly because the .thens tell you the exact order that your operations are going to fire. And so it's much more easy to follow the order of operations. But this is just a really simple example. This just has one .then and one .catch. We're going to build one together with two thens and one catch, just so you can get a sense of how you can chain this stuff together and pass data between the .thens. Whew, that's a mouthful. So any questions before we do a little bit of a code along? I'm going to stop my share. And we're going to try to do this in Replit. Again, we should be fine. Just make sure that we clear everything out of our cache. But any questions before we do a little bit of a code along and see one of these in action?
I just looking at it, it seems like you could do the same thing with callbacks, minus the catch function. That seems new, but breaking it out into separate functions rather than chaining them or nesting them, it seems like it would do the same thing.
Well,
what functionality does this add besides catch?
Well, the .then, and if you look at the .then and the .catch, they actually take callback functions, if you want to be really semantic. But this example only has one .then. For lab time today, I'm going to give you a dense piece of code with callbacks. I'm going to have you refactor it using promises. And I think you'll appreciate how much more concise, how much more readable the code is. There's some other advantages to using promises like under the hood if you want to read their documentation. But for now, it's really, again, callbacks and promises, they accomplish the same thing. I just think you'll find that promises, it's a more elegant, current way to handle asynchronous operations, and it reads a little better. So this is something, again, with databases, as you get into APIs, authentication, you're probably going to run into promises just because it's kind of more of a best practice-y way to do stuff nowadays. So just want to make sure that you guys are aware of it. You don't have to be experts at it, but promises will come up in a technical interview at some point. And as long as you have, some working knowledge of it, you'll be in good shape.
And you can nest them the same way. I guess you wouldn't want to, since that's what you're trying to get away from, but.
Yeah, if you're going to use promises, you want to adhere to their best practices. You wouldn't want to nest promises. You want to play within their sandbox. Yeah. Again, if you're comfortable with how callbacks read and you can read them with some sort of ease, then I would say go for it. However, most people can't. And if you nest 1 or 2, 3 callbacks, it starts to get super messy and you get that callback hell. So I think you'll find if you're working on a team of folks, at some point, they're probably going to have some sort of style guide or rule of thumb, if you will, to maintain the code and make it more readable for other people. And so that's why promises would be a really valuable skill to have in your toolkit. So we're going to build an example together just to see what this looks like. So I'm going to share my screen. If you guys want to go to Replit and open up a new Replit, we'll walk through building one of these and see if you have any questions about it. I'm going to share my screen. And let me clear out my stuff here. Cool. So I'm going to start, if you're following along in the README, if we have any issues with the screenshot share, although I think it's all good now. We're going to start at this promises example section. So what we're going to do to see an example of promises, you can think of a promise as an IOU in real life. So for today's example, let's say that your kid, let's say that you have a kid, if you don't, let's say that your kid promises to clean his or her room by the end of the day, okay? So it's like Tuesday morning, a long weekend, the place is a mess, and your kid told you this morning, I'm gonna clean my room by the end of the day. So he's giving you kind of an IOU, right? Expect this to be done by the end of the day. If he or she doesn't, I'm just gonna use he for ease of the pronouns. If he doesn't clean his room, the promise is gonna fail, right? He promised he would have it clean. Yeah, value rejected, thank you. Audrey, maybe this will hit home. So the promise will fail. Further, let's say that we also have a taking out the garbage function that depends on the room successfully being cleaned. So I can't take out the garbage until I clean my room, fill the garbage bags up with garbage, then I can take the garbage out to the garbage, to the trash can or whatever. So taking out the garbage depends on the room getting cleaned first, successfully. Also, once the room has been cleaned and we've taken out the garbage, then as a reward, we're gonna go get ice cream, okay? So we have 3 operations that we're talking about: cleaning the room, taking out the trash, and then if both of those are successful, we'll go get ice cream as a result, kind of as a reward. So that's the contrived example we're gonna play around with to build a promise that would mimic that scenario. So to start, we're gonna, using the promise constructor, we're going to create a new instance of a promise to get started. And I would encourage you not to copy this code to the extent that we can help it. And there aren't a ton of typos, which I'm prone to do. Let's create a variable called promise to clean the room. I know it's a little semantic, but so promise to clean the room. So we're going to create a new promise object. So this new keyword should be familiar from this morning. So JavaScript, there's a couple of different libraries that you can use to create your promises. JavaScript, particularly the new version, ECMAScript 6, has a promise library already built into it. And so we're just going to use that for now. So when we call new promise, we're calling JavaScript's version, its constructor function of a promise. And most of the time, that's fine for our purposes. But as you get a little bit more savvy with this, maybe there's different libraries that you would use for different use cases. But JavaScript does have this built in. Now, our promise constructor takes a callback function. And don't let that confuse you. Even though we're using promises and it's going to make our code more succinct, we're still going to be throwing callbacks here and there. We're just not going to be using as many by a long shot. So promises take a callback function, and the basic callback function, as we discussed, takes a resolve and a reject handler. And this is kind of, I'm trying to keep this as boilerplate as possible. So this would be our basic structure. Let me make this a little bit bigger. And then in here, I'll just put some pseudocode. Cleaning the room code will go in here. So whatever logic, whatever code we want to do to clean the room, that's going to go inside of this function. And just reading those bullet points from the screenshot, so we can use the new promise constructor function to instantiate a new instance of a promise. So this is pretty much what we did this morning, right? We're going to create a new promise, and we're going to assign it to this variable called promise to clean the room. And we're doing that so we can chain other stuff onto it. And so that's why we're assigning it to a variable for the most part. Promises take a callback function with 2 arguments. This is from their documentation. It's pretty straightforward. Resolve means the promise is fulfilled. So we'll write some code in case it's fulfilled. Then we'll also write some code in case this promise is rejected. So those are the 2 states. Remember that it's either fulfilled, rejected, or it's pending, just meaning it's in process. Now, let's set up a status based on whether or not the room has been cleaned. So we're not going to go through the details of like pulling out the vacuum cleaner and dusting and making the bed. let's just create, for simplicity's sake, a variable, and we'll call this isClean. And so we can test this out and stuff. We're just going to use a Boolean to test out our rejected and resolved logic. So go ahead and create a variable isClean. It's just going to be true or false. We're just going to keep it simple. Now below here, based on whether the room is clean, whether that promise has been resolved or rejected, let's put some if-else logic in here. So if the room is clean, meaning that the promise would be fulfilled, then we're going to have the resolve handler. And so the resolve handler, this is what we're going to pass into the .thens. If we want to chain other operations, we can pass whatever we pass into this resolve handler will get passed into the .then. And we'll see that because we're going to put some .thens on here. But this resolved handler could be anything. It could be a message. It could be new data. It could be something we do to some sort of data. It could be another API call. But for now, we're just going to pass in a string so we can see how it works. So if isClean is true, we're just going to send a string of clean to our resolve handler. Else, if this is rejected, we'll send not clean to our reject handler, like so. So if you're looking there in the README, I'll put some comments in here. So this will fire if function is true, or if the promise is fulfilled, rather. And then this will fire is rejected. Let me, I'm going to say resolved instead of fulfilled, just to kind of keep our terminology consistent. Cool. So this is the basic structure of a pretty kind of boilerplate type of promise. So we instantiate a new instance of a promise using new promise. Then we'll put some sort of code in here about cleaning the room. And then based on if that promise is fulfilled, resolved, or rejected, we have a resolved and reject handler where we can, keep those operations chained together. Cool. So that's our first step. I'll put this into Slack just in case anyone's lost or missing some code, if you have any typos or anything. So we're not going to run this code yet. We're going to add a little bit more to it. But that's kind of our step one. Any questions about that, kind of instantiating the first step, actually creating a new instance of a promise? Let me close my DevTools there. Okay, cool. So let's take a look at our first then. So let's chain another operation, an asynchronous operation, to this promise. So promise to clean the room, we assigned a new promise to that variable. So down here, I'm going to chain some more activity, some more behavior based on if this promise is fulfilled or rejected, resolved or rejected. Fulfilled is such an easier thing to say, but it's the same thing. So I'm going to grab that promise to clean the room variable, which contains my promise, and let's put a .then function on there. And even this .then, kind of the basic structure, is this going to take a callback function, right? So remember, promises still incorporate callbacks. They're just not as many of them, and it's a little bit easier to read. So just to see how the resolve and reject handlers work, if promise to clean the room, if it returns true or if it's successful, then let's console log as a first step the result of that resolve handler. So up here, if it's resolved, we're just going to console log the word clean. Essentially, that's what we're going to do. And so into this then, the callback function within our then, I'm just going to pass in a parameter, and I'll call it from resolve. So whatever we pass in here, we're going to have access to it. It's essentially this right here. So resolve, and then what we pass in is essentially this callback function here in our then method. And we'll see how this works. So inside this console log, I'm going to use backticks because I'm going to use string template strings right here. So make sure it's not a single tick, it's the back tick. So I'm going to do the room is, and then let's just console log whatever we passed into our resolve handler right there. So essentially, I'm going to be grabbing the value from resolve. Then we'll run this code and let's just see how it all works out. So I think we should be able to see. I'm going to clean that up. Let's run this code and see what happens so far. Run that one more time. Cool. So at this point, we haven't put any kind of like error handling in here with our dot catch, but you can already kind of follow the logic here. So we created a promise, and right now we're setting that promise to true, meaning that promise has been fulfilled for argument's sake. So if the promise is fulfilled truthfully, then whatever happens with this resolve is what's going to get passed into our dot then method. And so the dot then takes a callback, and we're essentially just passing in. So this from resolve is like passing in that clean, right? So that's kind of the same thing. Or maybe a better way to say it, it's resolved and passing in clean. So it's essentially like doing that right there. We're just passing in whatever we pass into our resolve callback is going to get passed in right here into our dot then. And so when we run this, we get the room is clean. So whatever we pass into our resolve handler is what we're going to get console logged out there. So the room is clean, ready to take out the trash, for example, just for argument's sake. So if I run this again, now I get the room is clean, ready to take out our trash. So then Audrey asked the question, is it safe to say we can do this as well with the reject? Yeah, so the reject is pretty much the same, except for the reject, instead of using dot then, we're going to use a dot catch. That's going to be the method that catches errors from the reject. And so we're going to chain that on later. But yeah, it's the same principle. And actually, if you were creating a promise, this is pretty much up to you, like your taste or whatever. But the great thing about promises is you can chain them together, right? So I actually, to make this more readable, maybe I would actually have my promise to clean the room. And this is usually how I do set up my promises. Then on the next line, I would do dot then and do that dot then. And then if I wanted to chain another one, I'd put it on that next line. So again, it's very procedural, and it makes it a little easier to read than having that callback hell with the triangles and such. That's pretty much up to you. If you want to have, you know, you're just chaining these together, kind of like jQuery, right? You can chain stuff together in jQuery. Whatever is more readable for you, I would say, like, go for it. I just, most of the time, I prefer reading it like that because I can read it really well. Any questions about that? So we took a look at the dot then method, which essentially takes a callback that handles whatever we pass into resolve right here. Let's clean that up. Okay, cool. So let's move forward. I think we're doing pretty good on time. So like Audrey mentioned, let's actually add that dot catch method. So right now, the promise is resolving, no problem. But what if we set the var clean to false? So the room didn't get cleaned, garbage didn't get taken out, and there's no ice cream in the picture. It's pretty bummer of a Tuesday. Okay, so for a reject condition, we're going to use the catch method. And it's pretty much the same pattern. We're going to have from reject. So now, instead of handling the resolve, we're going to handle whatever happens in the reject, whatever we pass in. So we can do something similar in this example. Let's just console log the reject handler. So I'll do the room is, again, make sure that you're using those backticks for template strings. From reject. So if it's resolved, it's going to use this. If there's a rejection at any point in our chain, the .catch will catch it, if you will. So let's run this and let's see what happens. So now when we run it, we're making the assumption that the promise is unfulfilled, that it's rejected. Make sure to set your isClean variable to false. That's just how we're kind of like hacking this thing together right now. So since isClean is false, the reject handler will fire, and which means it's going to go down to our kind of our safety net, our .catch. And so that's why we get the room is not clean. And that's our that's how our reject is handled right now. Now in real life, maybe you'd actually want to, set up a schedule. Okay, then you're going to have to do this again tomorrow, or no ice cream for you. I don't know, whatever condition you want to happen on a rejected promise. You can put that code in there. But the beauty of catch, again, with our traditional callback structure, anytime we create a callback function with some sort of operation, we would need to create an individual error handler function for each one. But as we chain other .then methods to our promise, which we're going to add 2 more, as long as we keep that .catch kind of at the bottom of our chain, it'll take care of any of the error handling. So if any of these .then methods, any of these handlers, if any of them are rejected or if any of them fail, that error is just going to trickle down and then get caught by our .catch, which is, again, a very nice, succinct way that promises helps us to dry up our code. All right, cool. Let's actually, I think we're just going to add one more. Well, we'll add one more, then I'll give you guys a few minutes to add a third one. But let's add one about taking out the trash here in the middle. So after we promise to clean the room, let's refactor this just a little bit, make this a little more fancy. So remember that we can pass information between these chained then handlers. So after we console log the room is clean from our resolve, just for an example, let's actually see what it's like to pass something, to return something from this .then down to the next one. So we can just pass information down the chain, right? So let's see what that looks like. So let's put a return value in here. And we're just going to do a simple string, nothing too crazy. Let's take up the garbage. So we cleaned the room. We pass in that clean to our first .then handler. We're going to console log the room is clean. And then let's pass a message to the next handler that'll handle the garbage collection. So let's just return a message that says, let's take out the garbage. Now, the way that we can chain these things together is whatever we return from the previous .then method gets passed into the next function as a parameter, the next .then. So just to see how this works, I'm going to name this parameter message. So whatever the return value is from the preceding .then is going to get passed into the next .then. So that's how we just pass these things down the chain. And then let's see a simple example of that by console logging the message object, just to see this thing pass down. So when we run this code, also we need to make sure to change our variable to true. So our .thens will fire, not our .catch. So when we run this code, we should see the room is clean. And then we should see, let's take out the garbage, which is going to be console logged here because we pass it down to the next .then. So let's see how that works. So we run, hit run, and then we get the room is clean, which is coming from this .then method. And then we're passing in the string, let's take out the garbage, which we're returning here, which means it gets passed into the next one. So again, if we were hitting the Rotten Tomatoes API, maybe we hit the API and then maybe we pass that data into the next .then method, so we can parse it, or so we can, like, you know, create some DOM elements for the poster and the, you know, actors and the release date, things like that. So we can chain these things together, which is pretty nice. Cool, so that's 2 thens. So we've cleaned the room for argument's sake, and then we're taking out the garbage. Let's take a few minutes, and I want you guys to add a third .then, just to pretend that we're handling that, you know, grabbing the ice cream scenario. So go ahead and take a few minutes, add a third .then method, just chain it onto our promise. That will console log, the room is cleaned, garbage is taken out, now let's go get some ice cream. So just add a third .then that will accomplish that. Right now we're just console logging strings. We're not really putting any logic in here, cleaning or taking out the garbage logic, but just to pretend that we are. So go ahead and work on that. I'll stop my screen share and we'll see what that looks like.